let's now practically prepare our data set. We define the train directory and then the word file directory, which is this. Then there is a destination directory which is going to contain all the images. Now recall that with the train directory we had several other directories with each directory representing one class. Now we want to put all those images in one directory, which we call train all. We can use this piece of code to copy all the images in each subdirectory found in this train directory into this one directory dst. This is done using this copy tool we import from shoottool. Once this is done, we have this train all directory which contains all those images. We have the 100,000 items right here. So we'll go back. This was our train which had for each 500 times 200 is 100,000. Then we go ahead to define a dictionary which is going to contain each and every category and its corresponding ID. So like, let's run this and print out dictionary. Let's just get output of this dictionary. So we have this right here. So we have each category and its ID. So we'll go through, we have the 200 different categories. Now how this is done is by simply going through the train directory, which was this, and then the dictionary I, because I, or let's print out this before insert above. No, let's insert this just above here. Okay, so let's print this out. Let's print out this list. Printing this out, we have this train directory which is made of all these different directories. So here are the 200 different directories contained in this train directory. Now what we do is we go for each and every one of them, given that they contain this unique name. So for each and every one of these, we'll say directory, for example, N01443537 directory, or dictionary I, which in this case is this. So dictionary this is equals K, and K starts from 0 right up to the last value of this list. So that's how we obtain this dictionary, and this dictionary will help us, as we shall see, to be able to link the images and their corresponding categories. So at this point we have this train all directory which contains all the images. Now if you pick out each and every one of them, you'll notice that they actually have this similar pattern in the naming. Like right here we have N01443537, and then there is this _4.jpg. So the first 9 characters represent this category, and then the 4 is to say is a food image. So if you can go right, select another random like this one, we still have the same. We have the first 9 which represents the category, and then the underscore, and then the image number. So using that, we shall be able to say that an image belongs to a particular class, basically using this dictionary, because once we have its category, we can give it a particular output, whether 0 or 199. So all these values, we shall simply get the image file name, and then from this file name extract this value, compare and see which of this corresponds, and then give it any of these indices or any of these categories between 0 and 199. So let's have this. We have defined x, which is a variable of shape 100,000 by 64 by 64 by 3. That's because we have 100,000 images, and each of them are of shape 64 by 64 by 3. And then we have y, the output, 100,000 different outputs, and each of them can belong to 200 different categories. Now for this, let's run this separately. Let's do this right here. For I, j in enumerate this, let's consider we're taking the list from 0 to 2, for example. So we'll print out I and j separately. enumerate is not subscriptable. Now that's because we were supposed to do the subscript this way. So 0 2, run it. Okay, so right here we have that for each image in our trained images, we are going to go step by step. Now we are just subscripted to work only with the first 2 images. So for the first one, we take we start from 0, and then we collect this file name. Then we move to 1, collect this, and so on and so forth. So if I increase this to 200, see that we move on this way very easily. So that's it. This will permit us to have, when I is 0, for example, have x 0 and y 0, and then for the next step we shall have x 1, y 1, and so on and so forth up to x 100 or 99,000. So we shall go right up to 99,000. So let's take this off and see. Run this. How does this look like? See, this takes us right up to 99,999. So this is gonna give us y 99,999. So let's get back to this. So for each ij, then now for the image, what we do is we have this tf.keras.preprocessing.image.load image, which permits us load these images based on the file names. Now to get the file name, we have the train images plus j. See that right from here, j was basically this file names. So these are the file names we get. So we get for each and every one of the images their file names. The color mode is RGB. So that's how we get image. And then to xi, so at the beginning, that when I is 0, we have x0. So to x0, we shall assign this tf.keras to image of image. So this is a function which converts an image to an array. So we have this image to array of image. So this is an image and it's now converted to an array, and that's why we put in this x. And then for y, we are going to put a value, or we're going to convert or take a value which is from this dictionary and then convert it to a one hot notation. So let's say, for example, let's take this off. Let's say, for example, we have this dictionary J09. So let's take this, or we could even take from here. Let's come back right here. Let's copy just this part where we had this dictionary. Run this. Let's print this out. Then I'll select, say, the first 2. Okay, so right here we have the ij as usual, which we could comment, and then the dictionary of this. So before printing out this dictionary, let's print out j from 0 to 9. If you print out j from 0 to 9, you will see that it doesn't contain the .jpeg. Let's print out j itself. See, this is j, and then j from 0 to 9 doesn't contain all those other values which are not important for us to know whether this image belongs to a particular class or not. So let me print out j separately, so you see. So that's it. So we have this is what we have, j. This is j from 0 to 9, the first 9 characters, which will permit us know which class a particular image belongs. And then with the aid of this dictionary, which maps these characters to a particular category, we have now, if we print out dictionary of j 0 to 9, we have an error. This is not callable. This actually this. All right, so this, let's comment this part. So this tells us that the image we're working with is the category 0. So basically that tells us already which class this image belongs. And now once we have the images class, we may decide to leave it like this and then maybe apply a sparse categorical cross entropy loss, or if we want to apply a categorical cross entropy loss, we can use this one hot notation. And for the one hot notation right here, you could just say tf the one hot of, if you take for example 2 and then you give it a length value, so if you say 10, you see the TF the 1 hot we're gonna get from here. So we have that, it gives you this array of length 10, and then on the second spot we put a 1. So that's basically how this TF that 1 hot functions. So right here, once we have that, we get 0, we can convert this to a 1 hot notation very easily using this TensorFlow function, and then we assign it to the output. Then we could print this out to see the evolution of the creation of our data set. So we could run this now. Finally, we have this internal error, which is simply because we are trying to allocate this huge tensor in our GPU memory, which is limited. So another way to go about this is to define this in NumPy such that our GPU is not in charge of storing this. So we can come right here, we have x, which is a NumPy, we have np.zeros. Right here we have np.zeros. Now our CPU will be in charge of storing this since we're using NumPy. Take this off, we have this right here. Then again, take this off. Alright, so we've gotten that. Now we'll take this, we'll write this to, this becomes equals, take this off, equals, take this off. So that's it. Now we have this TF the 1 hot. We take off this TF the 1 hot. We shall define our 1 hot function ourselves since we're not using TensorFlow. Then we take this off. We define the 1 hot right here and we test it. So if we define a 1 hot, we should have something like this. Here we're just using a list, and then the input value or the output of input value is 1. So that's how we get this. Send this to 1, for example. See here, send this to 0. We have that. Alright, so that's it. Now that we have this, let's try to run this and see what happens. So we see that it actually works. Then another way we could go about this is by enclosing this TF code in this with tf.device and selecting the device to be a CPU. Let's now reduce the size of our data set so that we could see exactly what's outputted after getting the values for X and Y. So let's take this off, run that, and then we have this error because there are many more items in the training images. So basically we could say if it's greater than, say, 99, because we have 100 elements, so it's greater than or equals 99, we're gonna break. Take that off, run again. Now we could print out X shape and then Y shape. And obviously from X and Y you could break this up into the X train and then the Y and Y train and then the X val and Y val. Apart from getting the values for our data set as, say, an input X and an input Y, we could also use TensorFlow's data.dataset package, which comes with several methods. Now, some of the advantages of converting our TensorFlow, or rather our variables, into TensorFlow dataset is that transformations are made easier when you're having a TensorFlow dataset. We shall look at this shortly when we will be doing data augmentation. We'll see that it's very easy to do data augmentation when our dataset is in the form of a TensorFlow dataset. Then training can be done more efficiently using the prefetch and the catch and the cache methods, which come with a TensorFlow dataset. We could also easily iterate through our dataset when we're working with a TensorFlow dataset. That said, this input we have right here could be converted into a TensorFlow dataset using the from tensor slices method, and this is done quite easily.
Basically here we'll define this dictionary, which takes in the name of the variable, and then this one takes in the name of the variable and the variable. So we'll see how we've broken this up into the trained data set and the validation data set. We could also simply just come up with the x and y directly. So we have this x and then y. Let's run that, insert a cell below, and now we have our trained data set. We'll see that we have this tensor slice data set of shape 64 by 64 by 3, and then we have the output y of shape 200. Then we have the data types here. We could also put this into batches, so we have a batch and specify a batch size of say 32, and then we'll run that. See, we've included the batch dimension, include the batching. Then we could also include caching directly and also the prefetch. Now the role of the caching and the prefetch is actually to make training on this data set more efficient. So here we have the prefetching with auto tune, where the auto tune we have, as we've seen here, is from the TensorFlow data.experimental. So that said, we'll run this again, and our data is now set for training. For a common task like classification, TensorFlow makes it very easy to prepare the data set. Generally in classification, we have several classes, and the way the data set is structured is such that in a folder you have some other subfolders where each subfolder contains the images for each and every class. So suppose we have this folder or this main folder. We now have the folder containing all images in class 1, this for class 2, for class 3, up to class 200, since we have 200 classes in our case. Now, if our data is structured in this way, we could simply use TensorFlow's image data set from directory. Let's see how that works. We have the image data set from directory, which takes in the training directory. This training directory is the main folder we have here. So if we get back to this, we have a main folder here, the train, where for every subfolder we have the different classes. Now this means that if your data set doesn't come in this order, or if your data set has a folder and that in that one folder you have all the images, then in order to make use of this, it's going to be advisable to break up that folder into all these separate classes folders. So if your folder doesn't contain all this, you could recreate your data set such that it comes this way, so that you can make use of this TensorFlow's method. Now that said, we define the main folder here, or the main directory, which is this. So we'll specify it. We'll specify the validation split. So that's how easy it is to break our data set into validation and training. By default, the data set is shuffled. So if you don't want it to be shuffled, you could specify shuffling. You could say shuffle to be false. By default, it's true. Anyway, we want it to be shuffled, so that's it. The subset, since we're creating the training data set, we'll specify training. The seed. Now the use of the seed is because if we are trying to shuffle our data set to create a training, then we want that same shuffling should be repeated, or the same way we shuffle the data set should be repeated when creating the validation, so that there's no confusion. And so we specify our seed to be 90 and the same seed right here. Then the image size is specified directly, so we just specify this. It means that if we have images of different image sizes, they automatically get this size, or they are resized automatically. So that's said, let's now run this and see what we get. The input dimension is not defined. We could define that here. We have the input dimension 224. Run this, get back to it, run again. We now see the outputs here. We're told we have 100,000 files belonging to 200 classes, and it's going to use 90,000 files for training, and then here we have 100,000 files belonging to 200 classes, and going to use 10,000 for validation. So basically we've created a validation and the training data set, and as you could see, we didn't go through all this process to create a data set. We just basically called this method. And what's interesting to notice that what this outputs is of type data.dataset. So if you print out the train dataset, see we have an already batched dataset. Now the batch size by default is 32. If you want to specify a different batch size from 32, you could specify it, say 256, and that's it. Let's take this off. We maintain the batch size is 32. Take this off. Okay. Now we have that. We could go ahead and then do the caching and the prefetching. So right here we have train data set equals that. Take off the batch because we've done the batching already. So that's it. We now run this, and then we have our train data set. So that's it. We'll run again. You see that we have our prefetch data set now, which is exactly the same as this. But then this has been done in just a few lines of code. Now that we've seen these two ways of loading our data set, there's actually another way, which is that of using data generators. Now the use of using a data generator is generally when you have large data sets which cannot get into memory. So since they can't get into memory, we use a generator or a data generator which permits us load only parts of the data set during training, so that we could manage to train very large data sets. Now we shall look at an example on data generators in subsequent sections.